Hey, in this video I want to go a little bit further using SDL, but first I want to take a look at the code that I provided. In this code I am using SDL and I created a class, the image class, that lets me just set pixels into texture, and then I can change those pixels and show them on the screen. It ends up looking like this. So I've got just a gradient blue down to white. And what I want to point out here is that this class it has a constructor where it allocates this texture, a place to store the image data on the GPU, and it has a destructor where it frees up that texture, that memory. And if you're paying attention, this is not following the rule of three for this whole RAII stuff. This resource acquisition is initialization. So I want to fix that. Now, dealing with textures is a little bit tricky because we're working with memory that's stored on the GPU, and we're trying to communicate with it through the CPU. And textures are really, they're on the GPU because they're meant for fast display. So you can get it from GPU memory to the screen really fast, really efficiently, and is not really meant for internal editing. So in the other parts of the rule of three, we want to be talking about a copy constructor and a copy assignment operator. But to copy this data would mean copying this texture, and in some way you might think that that's sending the wrong signals to whoever uses this class. They might start thinking that everything should be expected to perform well, and using a constructor or assigning and copying an image object is going to do something that performs well, and that might be misleading. In some cases it's fine, but ultimately we control that interface and we get to make our own best decisions about what functions to provide. So I'm going to make this easy on myself because it actually takes a few additional steps to copy a texture that I don't really want to go through, like setting up a render texture, the space for it, and then doing the actual rendering. So instead, I'm just going to disable these other parts of that rule of three. So here's a copy constructor, and I'm going to use this special syntax equals delete, which is really kind of a ridiculous way to do it. I don't know why they designed this syntax to mean that, but that's what they did. So I'm explicitly deleting this constructor so that it can't be used. If it is used, it'll come up as an error. And the other one is the copy constructor, or copy assignment. So returns a reference. It is operator equals, and it takes a constant reference to an image. Deleted. All right. Okay, so that satisfies the rule of three, because then you can't make bad memory issues pop up by copying these images, because I've just disallowed it. Okay. So let's move on to making this class work even better. I would like to not just be able to load or create space for pixels to change. I'd like to load an image from a file, and then I can have an artist make that file instead of me poking around at pixels. So let me set this up. I would like a different constructor. Let's use a renderer, but let's now specify string, a file to load. Okay, so the string type here, I haven't included that header, so let me make sure I have that. Include the string header, and then I'm set. Okay, the function I want to use is SDLLoadBMP. So loadBMP, it takes a file name, so here's my file name, but remember that this is a C library, so this function is going to expect a C string, not a C++ string class object. So I'm going to use the .c_str function, which gives me the C string representation of this string. Okay, now loadBMP returns a surface, SDL surface. All right, and so this is just a copy of that image, but in CPU side memory, so in your RAM. And I want to convert this, so SDL, where is it? Create texture from surface. There we go. So I'll specify the renderer and the surface, and then this will return the texture I want. There we go. Cool. So there's some other details, other variables I need to fill in. I do want the width and the height. I want to set the renderer, and doing some error checking would be nice. So let's try that out. Width and height, I don't really know those until I've loaded the image. The surface carries that information, so I can just use it. Surface is a pointer to an SDL surface, so I can dereference that pointer and access its W member. And surface H is the height. Okay, got those. Set the renderer, do some error checking here. All right. I have an extra step here loading the surface, and the surface loading could fail. So let me also put if surface is null, error loading surface. Okay, that seems pretty good. Okay, that seems fine for me. So it loads up the texture. What I could do to make this even more flexible is put this into a member function, like a load function or something, and not just in a constructor. And then I can use I could use the load function in this constructor and make it more flexible, a little nicer to work with. But I'll leave it like this for now. So what I'd like to be able to do now is move away from just setting pixels, a bunch of pixels, because that's really, really slow. It is much faster if all of the information is already on the GPU, and then the GPU can just slam that to the screen, blast it to the screen, and it doesn't need to wait for me to tell it what pixels are going to be on the texture. So that's why loading an image is so much better. I need to be able to draw this image. Let's see. Okay, it works here. We're using SDL render copy to draw that image onto the screen, and we're providing an X and a Y component, or position. It would be nice to have some sort of structure that encapsulates this part of the drawing, and so I am going to make another class. I'll call it sprite. So the sprite class is going to be just a simple combination of these things: the position where it's going to show up on the screen, and the image. So to construct one of these sprites, I'm going to have to specify all of the information I need in order to construct an image. Just because I don't have, I didn't create a default constructor for image, I want to call that constructor where you can tell it what file to load. Okay. So I've discussed this a little bit before. I cannot just use the constructor for this image object in this constructor, just in the body of it. There's no syntax to really support that. Instead, it's part of this initializer list syntax, colon, image, and then I can use its constructor. So renderer and file name. There we go. And then I can set this plain old data, these x and y normally. Just set them to 0. Seems good. Then I can give some functionality to this sprite. Let's say draw. We need, okay, it's got everything it needs. Yep. Image.draw to screen. Alright, so it's sort of passing down responsibility for making this happen to its sub-object here, image. And I think I'm pretty happy with how this looks so far. This is fine. So I'll leave it this way, so it's easy to access these data members. And all I need to do is load it and draw it. So now in my program, instead of creating this this gradient, I'm going to load a file, and so I'm going to need a file to load. I'm going to open up my project directory. So if you right-click on your project, open folder in File Explorer, brings you right to where you need your image to be. I can only load bitmap files .bmp right now. There are extension libraries like SDLimage that can load PNGs and JPEGs and whatever else. But I'm just going to stick to BMPs right now. So this is where it needs to belong. I have one here, smile.bmp. So I'm going to change my image here. Instead of loading up an image and setting its pixels, I'm going to create a sprite. I'll call it smile, and I'm going to construct it, giving it the renderer and the file name, smile.bmp. Okay, this whole thing, image needs update. I'm going to pull that out because that was because I was using pixel rendering and it was really slow, so I didn't want to do it every frame. There's also X and Y here, which I'm controlling inside this sprite object now. And so I'll just do my smile sprite. Okay. I don't need that anymore. Update image, I don't need that either. Not drawing those pixels. And then this call, drawing to the screen, is my sprite's draw call now. Smile, that's your name. Okay, and then I can free the smile's image and try that out. There he is. Okay. And pressing my arrow keys moves him around. Alright, that looks pretty good. So, one thing you should have noticed is how you control the motion of this sprite using key states. This is just a way of telling which key is being held down. You ask for a specific key, and it tells you true or false, is it being held down? And so you can make movement happen in that way. What I need to be careful of here is that for more complex games, this needs to be fixed. So needs frame rate independent Euler integration. That's important. So we will talk about that in the next video. See you later.